Hello and welcome back to the geometry series. And so what we're going to be talking about today are transformations, and the first of which are dilations. So with dilations, let's say that we have three random points to form a triangle. So let's say we have point 1, 3, or let's make that 1, 4 actually. And then points 2, 6, and 4, 2. So let's plot this on this graph really quick. So I just plotted these points and then I connected each of the points to form a triangle right here. So once we do that, so we'll call this our base shape. So this is what we have at first. So what we do to perform a dilation is we need a scale factor, and basically a scale factor is a factor to multiply all of these points by to get a bigger triangle, which would be like, for example, if our scale factor was like 2, it would be 2 times bigger than this triangle. So let's actually use our scale factor as 2 in this case. So let's write some new points. So if we multiply 2 by the first coordinate, we get 2, 8. So 2 comma 8. And then let's do the same thing for all the other points. So 4 comma 12. And finally 8 comma 4. Alright, so now let's just plot these points, these new set of points really quick. So as you can see, this new triangle that we formed, uh, basically it's 2 times bigger than this triangle right here. And these triangles are similar, meaning that each of their angles are congruent, or each of their angles are the same. Now, this doesn't mean that their length is the same, as we can just obviously see here, um, but their angles are congruent. Okay, so now what we would do for reduction is literally just like reverse engineering. So we take the bigger triangle here, which would be your original points, and now we have our reduced points. So let's say that we're going by a scale factor of half. Um, the key for reduction is that scale factor is going to be a fraction, so it's going to be between 0 and 1. Um, and the reason for this is because if it's less than 0, it's technically still a dilation. It would just be in another quadrant. Um, but yeah. Right now we're only working with one quadrant as we're in quadrant 1, which is positive, positive. Okay. So if we went with a reduction of a scale factor of half, we just multiply all these points by half. Okay. So yeah, these would be your reduced points. Okay, so now let's move on to a practice problem. So a triangle with points 3, 9, 6, 3, and 3, 3 is dilated by a scale factor of 1/3, and draw the original and reduced triangle on the graph below. Okay, so our scale factor is 1/3, and don't get tricked by the word dilated. So we're not increasing here, but like when you dilate by a scale factor of 1/3, just take that as multiplying by a scale factor of 1/3. So basically this is going to be a reduction here. So, okay, we know that it's going to be a reduction. Alright, so now let's plot our given points and draw the triangle. So 3, 9 is located right here. 6, 3 is located right here. And 3, 3 is located right here. Okay, now let's just connect the dots and form a triangle. And just get rid of these. Okay, so this is the given triangle. And now what we need to do is reduce these by a scale, or sorry, dilate these by a scale factor of 1/3, but it's a reduction. So we just need to multiply all of these by 1/3. So let's take the first point, 3, 9. And when we multiply 3 times 1/3, it's the same thing as dividing 3 by 3, so 3 over 3, and that equals 1. And then 9 times 1/3 is 3. So our first point is 1, 3. Alright, and we basically do the same thing for all the others, and I'm not going to go through the basic multiplication and division again. So we have 2, 1, and 1, 1. Alright, 1, 3 is right here. 2, 1 is right here. And 1, 1 finally is right. Here, let me redo that point. 1, 1 is right here. Let's connect it. Whoops. And that is our dilated but technically reduced triangle. Okay, so that's it for this video. And in the next video, we're going to be talking about rotations. See you in the next one.